In this video, we're going to discuss product and chain rules of differentiation. But let's first of all consider product rule. If y is equal to the product of u and v, then the differential value of y with respect to x is going to be differentiating u multiplied by v plus differentiating v multiplied by u. Or we can as well write it out this way. So let's take a look at some few examples. Number one, if y equal to x squared sine x, and then we have to differentiate y with respect to x, and then let's say u equal to x squared, then u complement is equal to 2x, that is differentiating u, it means 2x. Then if v equal to sine x, then v prime is going to be equal to cos x. Therefore our the y, the x, is equal to 2x sine x, okay, plus x squared cos x, going by a way of product rule, okay? And that's simply our answer. Let's take a look at question 2. If we're given y to be x cubed ln x, okay, so we have to differentiate y with respect to x, that is find the y, the x, okay? So we can actually represent x cubed with u, so u equal to x cubed, and then u complement, that's going to be 3x squared. The same vein, v equal to ln x, okay, so v complement is going to be 1 over x. Okay, I refer you back to my last video where I discussed briefly on how to differentiate natural logarithm like this, that is the differential value of x, which is 1 over x itself. Okay, and therefore going by way of product rule, okay, don't forget our the y, the x, product rule is u complement v plus uv prime. Okay, so let's substitute our answers into that expression that we have there, and therefore what we have there is 3x squared ln x plus x cubed dot 1 over x, that's multiplied by 1 over x. And of course we can use this, we can actually use this one to reduce this by 1, and therefore we're going to have 3x squared ln x plus this reduces this, that becomes x squared, okay? And therefore we can still use x squared to factorize so that our answer can be expressed in its simplest form. And therefore using x squared to factorize, that's 3 ln x plus what? Plus 1. So that's our answer to that question. So let's take a look at another examples here. Okay, and then going back with another examples. Okay, let's say that's my question 3. My question 3 is this. Question 3 says y equal to, let's say, 5x minus 9x cubed multiplied by 8 plus x squared, rather 8 plus x squared, and then we have to find the y, the x. Instead of using this one to open up the bracket and have a complex polynomials, we can as well simply apply product rule to solve this question. So in this case, our u equal to 5x minus 9x cubed, and then the u complement is equivalent to 5, that's the differential value of 5x minus 3 times 9, that's 27, that's 27x squared. And then how about v? Our v, it's going to be 8 plus x squared. That means v prime is equal to 2x. Okay, so that means our the y, the x, or the y, the x is going to be 5. Okay, let me write out the concepts. Okay, the y, the x is equal to u prime v plus uv prime. Okay, in this case, our the y, the x is going to be equal to 5 minus 27x squared, okay, multiplied by v, which is 8 plus x squared, okay, which is 8 plus x squared, and then plus the other one is u, which is actually 5x minus 9x cubed, okay, multiplied by 2x, and this will be our answer. We can just stop there and then move on to the next one. The next one says, number 4, if y equal to 4 sine x tan x, 4 sine x tan x, we have to find the y x. Okay, so we can just say u equal to 4 sine x, and then u prime equal to 4 cos x. I refer you back to my last video as well, where I discussed the differential values of our trig functions. So u complement is 4 cos x, and therefore v is going to be equal to tan x, and therefore v prime is going to be equal to sec squared x. Okay, therefore our the y dx, which is equal to this plus uv prime. Okay, so let's substitute that into what we have, and therefore what we have here, our the y the x is going to be equal to 4 cos x tan x plus 4 sine x sec square x. Okay, so in this case we can still solve further, okay, in the sense that your 4 cos x, your tan x, can be expressed as sine x over cos x. That's dot product of sine x over cos 4 cos x dot sine x over cos x, and then plus 4 sine x sec square x. Okay, and then we can cut out this and this, and then this is going to be 4 sine x, 4 sine x, okay, plus 4 sine x sec square x. Okay, and finally we can actually make use of 4 sine x to factorize the expression, and then we can write it out 4 sine x in the bracket 1 plus sec square x. So in this way the answer has been expressed in its simplest form. Okay, so let's move on to another example. Another example here, and that's going to be my number 4. Okay, I think that should be question 5, not 4. If a given y to be equal to 5x sine x minus x cube times x, so we have to find the y, the x equal to what? Okay, in this case we can actually apply product rule to solve each part. Okay, so for 5x sine x, we can apply for our 5x sine x, we can say our u equal to sine x, oh sorry, let me make use of our u to be 5x, and then differentiating u is going to be 5. Then our v equal to, so let this one be cancelled very well, our v equal to sine x, and then v prime is equal to cos x, and therefore differentiating with respect to x of 5x sine x can be expressed as 5 sine x plus 5x cos x if you use product rule for the first part of our question. And don't forget, the product rule is u prime v plus uv prime. Okay, let's take note of that. And that's exactly, I just substitute what I have here into the concept of product rule, and I have this for the first part. So let's go ahead for the second part, which is x cubed tan x, so that we subsequently combine everything together and we subtract where needed. So for the second part, we have x cubed tan x, so we can say our u equal to x cubed, and of course u prime is going to be 3x squared. And then what's our v? Our v is tan x, and then v complement equal to sec square x. So v complement is sec square x. And then we go ahead and apply the same product rule. So differentiating with respect to x, the second part of our question, which is x cubed tan x. Okay, and that's going to give us, just apply the same concept of u prime v plus uv prime, and then substitute what we have into that expression of the concept of product rule. And then what we have there, it's going to be 3x squared tan x plus x cubed sec square x. And therefore, this is the answer of the second part. Don't forget, this is the answer of the first part and then the answer of the second part. And then what we need to do now is to combine the two answers, okay? And therefore, finally, our the y, the x, if y is equal to this expression here, or the y, the x, is going to be the first part, the solution to the first part is this. And then we bring that into the solution here. And that's going to be 5 sine x plus 5x cos x now minus this one is 3x squared tan x plus x cubed sec square x, this part this way, okay? And then we proceed and then open up the bracket with this negative sign, and what we have here is going to be 5 sine x plus 5x cos x minus, using this to open the bracket, we have 3x squared tan x minus this minus times plus here x cubed sec square x, okay? And then we can still use because we have some kinds of x squared and x cubed here, we can actually use x squared to factorize that if we need to do that. But this is basically the answer, but our answer can also be expressed this way, and we can also use 5 and 5 here to factorize, okay? So we can write that out, 5 and a bracket sine x plus x cos x this way, okay, minus then the x squared is being used to factorize this, that's 3 tan x plus x sec square x. So this is the final answer to our question. Then let's still take a look at some other rule, which is chain rule. So let's discuss chain rule this way, okay? I'm going to write it out this way so that subsequently we solve some questions that we need to apply both product rule and chain rule. Okay, the concept of chain rule is this: if your y is some kinds of u raised to the power of n, okay, and then that means differentiating y with respect to x is equal to the power itself multiplied by u raised to the power of n minus 1, then multiplied by the differential value of u. Let's just take a look. They take note of these concepts of chain rule. So let's take a look at some few examples of chain rule. Examples of chain rule. The first question here, if y equal to 5x plus 3 raised to the power of 4, okay, if you take a look at this, it's going to be more complex if you're writing it out like 5x plus 3 times itself in 4 places. That's going to be rather too cumbersome. So this is where chain rule comes in. Then if it is some kinds of questions like 5x plus 3, let's say square, you can just multiply this one by itself twice and then still apply power rule, and then you solve by way of just like solving polynomial kind of expressions. But the moment it's going to 3, 4 and above, then it's advisable you make use of your chain rule. So it's easier to make use of chain rule to solve questions like this. So let's apply the concept, okay, of chain rule to solve this question. In this case, our u equal to 5x plus 3. And then the u complement is going to be what? 5. That is differentiating 5x is going to be 5 and that's, and then don't forget the power, n equal to 4, okay? Therefore our the y the x will be the y the x in this case, that's going to be 5x, no, the y the x in this case now, if we apply, okay, I was meant to write out the concept of chain rule itself, okay? And then this, let's cross out this one, the concept of chain rule, the y the x equal to n on the bracket u raised to the power of n minus 1 multiplied by u prime itself. So let's make use of that to solve that question. So our the y the x is equivalent to 4. It has to be 4, which is the power, okay, in a bracket 5x plus 3 raised to the power of 4 minus 1 multiplied by the differential value of 5, of 5x plus 3, which is 5. and that is times 5. So in this case, we have 4 times 5 here, that is 20, and a bracket 5x plus 3 raised to the power of 3. So this becomes the answer to this question. So let's take a look at another set of examples. Let's take a look at this. Okay, here is question 2. Question 2 here. If y equal to 5 over 7 minus x cubed raised to the power of 4. So how best can we express this? Don't forget, we can still first of all express our y to be 5, then a bracket 7 minus x cubed raised to the power of minus 4. Okay, in this case, our u equal to 7 minus x cubed, and therefore differentiating u, that's going to be minus 3x squared. And then don't forget that our n, that's the power, equal to minus 4. And therefore, applying the concept of chain rule, which says that the y, the x, and that's going to be what? The concept itself says n in the bracket u raised to the power of n minus 1 multiplied by the differential value of u. So let's apply that here now. And in this case, we have, okay, the n here now is going to be 5. Since we have 5 here already, so we have 5 here. So it's going to be 5 in a bracket minus 4. That's n. N is minus 4. Okay, in a bracket 7 minus x cubed. Okay, raised to the power of minus 4 minus 1 multiplied by minus 3x squared. Okay, and then we press forward. This times this. That's going to give us minus 20 in a bracket 7 minus x cubed. Okay, raised to the power of minus 5, and then multiply by minus 3x squared. Okay, and then this can multiply this, or we just write it out this way: minus 20 in a bracket minus 3x squared, and then in a bracket 7 minus x cubed raised to the power of minus 5. And therefore, this times this is going to give us positive. So this is 60x squared in a bracket 7 minus x cubed raised to the power of minus 5. Okay, this is basically meant to be the answer, but we can still solve it further so that our answer can be expressed in its simplest form. And then the best way to express this is actually 60x squared, okay, multiplied by, since this is negative 5 there, so it can be 1 over 7 minus x cubed raised to the power of 5. Okay, and therefore finally this times this, it can be 60x squared, because basically this is like over 1 over 7 minus x cubed raised to the power of 5. So this is the answer to the question. And then let's take a look at another example. And then this is going to be my question number 3. Question number 3 asks us to find the y dx if y equal to 1 over cube root of 5x squared plus 3x minus 2. Okay, and then this one, we can simply write y to mean 1 over 5x squared plus 3x minus 2 raised to the power of 1 over 3. And therefore, our y, okay, can be 1 over 5x squared plus 3x minus 2 raised to the power of 1 over 3. Okay, and then we can actually literally bring this one up there, and therefore y can be 5x squared plus 3x minus 2 raised to the power of minus 1 over 3. So this can be written this way, and then we apply the concept of our chain rule. Okay, and then the chain rule, don't forget the power. The power itself is n, which is this one minus 1 over 3, and then our u equal to 5x squared plus 3x minus 2. Okay, that means u complement equal to 10x plus 3. Okay, then we can go ahead and, excuse me, So the differential value of u is going to be 2 times 5, which is 10x plus 3. Okay, and then we can apply our chain rule. That means the y, the x, equal to the y, the x, is going to be n in the bracket u raised to the power of n minus 1 multiplied by u prime, the differential value of u. And therefore, we can simply apply that to substitute into what we have. So n is minus 1 over 3. So here is our the y, the x, is equal to minus 1 over 3 in the brackets. This is 5x squared plus 3x plus 3x minus 2 raised to the power of minus 1 over 3 minus 1 multiplied by the differential value of u, which is going to be 10x plus 3 plus 3. Let's put this in the bracket. And then the next thing is to sort out this. And therefore, this can be minus 1 over 3, okay, in the bracket, 5x squared plus 3x minus 2 raised to the power of minus 4 over 3, okay, dot 10x plus 3. And then we can actually interpret this one, okay, this way, as that's going to be negative, this negative, okay, then this one can be 1 over 3 in the bracket 5x squared plus 3x minus 2, okay, raised to the power of positive 4 over 3 because that's come down there, and then multiply by 10x plus 3, 10x plus 3 this way. And then finally, the numerator, because this one is like over 1 as well. So numerator can multiply numerator, or denominator can multiply denominator. If I must write that there, that's multiplied by this. Okay? And in this case, we have negative 10x plus 3 in the bracket, everything over 3 in the bracket 5x squared plus 3x minus 2 raised to the power of 4 over 3. So basically, this is going to be our answer to that question. Then let's take a look at another example. And then I think this is question 3. Question 3 that gave us this. So let's move on to question number 4. Question number 4, we're given if y equal to x squared minus 3x, okay, raised to the power of 5. So we have to actually differentiate this. Okay, we have to find the y, the x. It's pretty easy if you want to apply some basic concept of chain rule. In this case, our n, which is the power, equal to 5, and then our u equal to x squared minus 3x, and then differentiating u, that's going to be 2x. That's 2x minus 3. And then the y, the x, is equal to the concept of chain rule says n bracket u raised to the power of n minus 1, okay, multiplied by the differential value of u. And therefore, let's put that into the expression. That is 5, and the bracket the u is x squared minus 3x raised to the power of 5 minus 1 multiplied by 2x multiplied by 2x minus 3. Okay, and therefore this can be written as 5 in the bracket x squared minus 3x raised to the power of 4 in the bracket 2x minus 3. And then this basically is the answer, but we can write it as 5 in the bracket 2x minus 3 in the bracket x squared minus 3x raised to the power of 4. I just decided to write it out in ascending order of the powers. So basically this is the answer. Okay, and then that's all we have for this video. Thank you. Kindly subscribe to my YouTube channels. Thank you.